Hi, statistics student. This video is chapter 2.3, 2.4. We are continuing this discussion on how to find outliers using quartiles. And last time we talked about 5-number summary. So the 5-number summary divided data into 4 parts, the lowest 25, and then median, and then the highest 75% percentile, and like that. So I am doing example 1, which give us a data list, and we are to find a 5-number summary using the one variable statistic calculator from LibreText. And then after that, we use it to find some answer some question. So last time we have some exercise data from some students or from some sample. Then we have minimum is 0. The 5-number summary is 0, 20, 40, 60, and 300. IQR is actually 40. Okay. And then the second thing they ask is what percent of students exercise more than 60 minutes? So want to draw the picture here again. So 0 is the lowest number. 20 is Q1. 40, is it 40? Is it 30? Yeah, 40 is median. Median is 40. 60 is Q3. And then 100 for some reason is really big. It's 300. So, but each number of data is 25%. So what percent exercise more than 60? So 60 is Q3, right? 60 is 60 minutes. So that how many people are more than Q3? That is 25%, right? 25% of students exercise more than 60 minutes. Because this is Q3. Q3 has 75% below, 25% above. Each one of them has 25% of data. You may say, wow, this is really long. Would it consist of more data? No, it consists of only 25% of the data because they are spread out more. The value itself is longer, but there's only 25%. So if it is 100 students, there will be 25 students, etc., etc. Now, after we introduce all this basic concept, we are to introduce how statistician decided to classify something in outliers. So this terms outlier in English just means extreme, extremely low, or extremely high. There is no subjective way of saying that number is an outlier or not, except in some very extreme case. But you know how is an outlier? So this is the agreed upon formula. So an outlier is if it is below a number. What is that number? The number is Q1 minus 1.5 times of IQR. That means you will have Q1 here, and then you would have Q3 here. This is kind of the box, right? You ignore the two whisker, which is the the last 25 and the top 25%. From here, you minus 1.5 times. So this is the IQR range. You go all the way. So this lower fence, this is the lower fence. So you have the Q1 minus 1.5 IQR. 1.5 times of IQR. From Q3, you do 1.5 times of IQR. And this is the upper fence. If data is within this range, is not an outlier. Outside this range, that is an outlier. So if you are so low that it is below 1.5 times of IQR, that's an outlier. If it is above 1.5 times of IQR of Q3, that is an outlier also. So this is an agreed upon formula, although recently there are a lot of discussion in statistics, a statistician that this is not a very good formula, we should blah, blah, blah. But for the most part, academically, people still use these two formulas. Okay. For example, if someone say, I have Q1 equal to 34, Q3 equals 70, what is the lower fence and upper fence? So first of all, we have to find the IQR number, which is Q3 minus Q1, 70 minus 34. This time I got it right, is 36. Then the lower fence is use 34 minus 1.5 of 36. So put in the calculator, when you put it in, put it in one shot in the scientific calculator, they will do the order of operation, do this first, and then they use 34 minus this. Okay, so don't do 34 minus 1.5 and press enter. So it is 34 minus 1.5 times 36, so that this will do first. Okay, so it's negative 20. You should try to use a calculator to make sure that you get negative 20, but not do it wrong. Okay, and this would be 70 plus 1.5 times of 36, so that would be 124. If you're not sure, you can do it with the Decimal scientific calculator, decimal.com. Decimal had a calculator at the corner. So if you look at this, like this, there's a here. So I'm going to do 34 minus 1.5, 36. Okay. 34 minus 1.5 times 36. Okay. So it's negative 20. So they will know the order of operation to do this first, and they would not do 34 minus 1.5 because it's a scientific calculator. So you can make sure you do it correctly, don't do it wrong. So after we do this lower and upper fence, we know that if the value between negative 20 to 124 are not outliers but value outside, meaning lower than negative 20 and higher than 124 are outliers. Okay, so to actually know these fences, you have to do this IQR and then do this calculation. Is there a better way? Uh, is there a better way to just look at a graph and then be able to tell if there's an outlier? There is a way. We use a graph called modify the box plot. What is a modified box plot? Basically, is a graph that is just like a box plot, but if it's an outlier after the computer behind the scenes check this upper and lower fence, it will flag it as an outlier by converting the data into a dots instead of on a whisker. So an example would be this. This is a modified box plot. I want to emphasize the fact that this is modified box plot. So it's not the regular one. The regular box plot is your box plot that you learn in middle school. This is not for showing, the distribution. Is the goal is to show outliers. Mark outlier. So you would just graph this, and if outlier exists, it would become a dots. The whisker won't go all the way to 300s. So in this particular case, the one that we worked on last time, I graph a modified box plot. I will know that there is an outlier of 300. I don't have to do the calculation and then check if there is any data that is higher than 124 like that. Okay, so I'm going to show you how to do. So how do you do this? The only way to graph the modified box plot is through this. Only way. Okay, and the data has to be in a column. Okay, if it's not in a column, you have to manually type it or use Google Sheets to convert the data into a column. So if you're interested in looking at the calculator video, I'll teach you how to convert it. So I'm going to do the example. Okay, so for example, I have my data already typed in a column, right? 0, 40, 60, 30, 60, all these. Okay, I have this data, the exercise data that I type in a column. It was in a comma format. See this 0, 40, 60, 30, all these. Earlier it was in a comma format, but I manually type in the column. Now I'm ready to put it in this and graph a modified box plot. So I will go to a browser and get to this. If you have auto data here, you do clear to clear everything out, or you do refresh your browser, everything will goes away. And then you do Control V. You copy your data here. If your data is in comma form, you laboriously type it in, or use Google Sheets to convert. Now, how do you graph? Where is it modify the box plot? Because I don't want to do any calculation. So what you do is you do data. Box plot, do you see? But they have two versions. One is the old one, which we do not want. We only want the modify because we are interested at using it to avoid calculating the lower fence and upper fence. So modified box plot, but I would tell that my column of data is in 1. Okay, modified box plot. See how this shows up as one high number at 300. So you may say, Ms. Chen, if there's multiple and then the graph does not show what exactly value it is, because when I hover over it, it doesn't show anything, right? So what can I do? You can toggle back to the sample editor. And if you want to clear the box plot, you can clear it. If not, you can just do data tool, sort the data. You would say, I want to sort one column, use column 1, because that's my data that I want to sort, and then sort them. So the data would arrange from small to high, and you would know that, oh, there is one highest number, and that's 300. Or if there's two, you would know, oh, the two highest is the outliers, or the two lowest is an outlier. In this case, they are not outliers, but only the 300 is, but not 120. Okay, so that's an example on how to find outliers by just looking at the graph. So it's really powerful. I can actually show you if, okay, so I have other data here. So maybe in the first column, I have some commute time, so I can try it. Okay, copy it. So someone's commute time is like 75 minutes, so copy it. And then again, toggle the sample editor. Oh, I'm going to just get rid of it. And I'm going to copy and paste in the second one. So I don't know if there's an outlier. So what I'll do is I will copy it in, and I say data, Boxplot. Always want to do modifies because you just want to see if there is an outlier. So click column 2, modify the boxplot, and look at left and right. Oh, there's nothing, right? No dots. That means the whole data set does not have outliers. You don't have to sort it because all of them are just normal data. There's no outliers. So you don't have to depends on histogram to determine if something is an outliers. So go back here. So that's all I have for outliers. So basically, most of the time, I do not need you to calculate the fences, but you need to know how to, if you know how to do the modified box plot, you can quickly check if there's an outlier in your data sets. One caveat is your data has to be in a column. Okay, if it's not in a column, you need to enter it one by one into StatDisk. Okay, and there is no alternative. This is the only way to graph the modified box plot.